At any point, if you cannot hear me, please try to call my attention because I may not hear you. Okay, so good afternoon once again. Um, we'll be starting, we'll be introducing ourselves to machine learning today, even though we did a little bit of introduction yesterday. So we'll continue from where we stopped yesterday. So today it may be a bit technical. So can someone type it on the group that we started the class? So in case people still want to join, so they will meet us in the class. Okay. So while we are doing that, so let's just listen and we have a long way to go today also. So let's go to our new notebook as usual. So today we'll be introducing ourselves to machine learning, even though yesterday I talked about what machine learning is and the types of machine learning. So let me just remind us or yeah, let me just remind us or let's go through what we discussed yesterday. We said machine learning is a technique of us teaching machine what we want it to know, and without us, the machine will be able to predict or analyze or able to recognize whatever information we've put or we've decoded on it. So, and we have two types of machine learning. We have the supervised learning and we have the unsupervised learning. And I discussed about the difference between the supervised learning and unsupervised learning. Supervised learning is us feeding the computer, or in this case, the machine learning model with labeled data, while unsupervised learning is us feeding the computer with unlabeled data. So today we want to look at, okay, how do we get to implement these? How do we about machine learning and stuff like that. And also, we all know that machine communicates in numbers or in binary number. Not only binary number, actually, I think there are different model. I can't remember now, but we do call it one name like that. That computer can accept number between 0 to 9, so they can still understand numbers, but they cannot understand all the A, B, C, and D. So when we see anything like this, all these file edits, all these things, they are code. They are um the instruction given to the computer were numbers, but were written in English text. So ordinarily, you do not expect your computer to understand all these English words. So now let's just start with our title, which will be Introduction to Machine Learning. Okay. So what are the what are the necessary libraries to import? So can someone tell me what are the necessary libraries to import to our Panda? Sorry, our what do you call this thing? Machine learning or Python, Jari? Anyone, just unmute your mic.
Pandas as PD,
Import
NumPy
pandas.
as NP,
Okay, I can
run
hear you
as
continue.
CNS as SNS, and Matplotlib, PyPlot as PLT.
Yeah, is it correct like this? Is it correct like this? Can you see the
Yes,
screen? Okay,
yes.
so we actually do have more than this library. These are just useful for data analysis in Python. So when we use pandas, we import pandas to um, for data analysis, basically for analyzing our data, then NumPy to perform arithmetic operation in Python. Then we also have Matplotlib and Seaborn for visualization. And I've already said this countless times that the processes of data analysis range or start from getting the data to cleaning the data, which is data transformation, and then analysis of data, then visualization of data, then the last one is reporting. So using pandas and NumPy, you can use it to get your data, clean your data, and analyze your data. Then the visualization can be done using your Matplotlib and Seaborn, which is basically all the libraries we have been importing since these days. But then because you are advancing to the next level, which is what we have done with data analysis is more like we have prepared the data set to be used. You understand? We were given a raw data set. We've cleaned it, we've analyzed it, we've gained some insights there. We can do some stuff there, we can clean it, we can get some values, we can derive some knowledge using um our data analysis uh, skill. So, okay, what if, and you know data analysis is you using the past data to make an informed decision. But now we want to project into the future. So let's say something happened yesterday, or let's say you are a store owner. So I'm trying to break it down so everyone will understand because it's a bit technical and everyone has to understand before we move on. So let's say I'm Rafiat now, you're a storekeeper. You know every January what sells in your store is sweet. Every February, what stores in your stores is biscuit, and every March, what sells in your store is let's say books. Let's just say stationery. So, and that happened in the year 2024 and 2023. So, you preparing for a new year, that is 2025. What do you think you will stock up during in the next January? Rafiat, I'm directing the question to you. What do you think will be your most most concentrated stock in January 2025?
What sell most in January?
Which used to sell sells the most in 2023 and 2024?
Is it like, am I not getting the questions? Please, can you
Okay,
come again?
let, let,
Because I'm, yeah.
let me just write it here. So 2023, 2024, 2025. Yeah, a storekeeper, right? So what sells the most in January? Let me just write January, February, and you have March. What sells the most in January is fruit. The same thing for this one. So for February, what sells the most is biscuits. The same thing for February. The same thing for 2024. What sells the most for March is stationaries. We are stationaries. So now you want to stock up for 2025. You are preparing for a new year, right? So you want to stock up for 2025. What do you think you will be stocking up in the first month, which is January?
Street.
What do you think you will be stocking up with?
Because I've been having the records that in the past years I've been selling sweets more than the others.
Exactly. That's what happened in what do you call it, in data analysis, using the past decision to make informed decision today. You get. But now data science or machine learning is more like, okay, what should we be selling in 2030? Do we still think, what if people might not like sweets then? What do you think we'll be selling in 2030? Will it be biscuits now or will it be stationary? So we projecting into the future is what we refer to as data science or machine learning in this case. So now we need different type of like this there. So it may be a bit technical, but I want us um to understand it very clearly. So you write from, so we do have a library called sklearn. So inside out your sklearn, we have different type of libraries there. Sklearn is more like what do you call it? Let's say like a faculty. Do you get? It's more like a faculty. So sklearn is more like a faculty, and we all know that in each faculty we have different courses. Let's say, for example, faculty of engineering. Now we know we have mechanical engineering, and we have all those type of engineers, civil engineering, elect. You know, we have different type. The same thing with sklearn. So the first thing you want to write is from sklearn. So sklearn is a library, but then we have a lot of things that's going on inside the library. Because I know the data I'm trying to import here, I'm trying to pre-process some of my data. So after I'm done with from sklearn, please, if you don't understand, please try to call my attention. So I've increased the brightness. Sorry, I've increased the lettering so you can see it better. So if you don't understand, it's a bit tricky. sklearn is a library, but then you have to know, okay, because it's like a faculty, because you have to tell me, okay, what department do you want there? Because I know I will actually be pre-processing my data. The data set I want to load uh inside my inside my Google Colab is something that has English words. So I know I have to pre-process it. I have to process it from English words to number, which is why I'll be writing sklearn dot pre-processing, because actually I want to pre-processing. So now it is more like calling sklearn is the name of the faculty, right? Pre-processing is the name of the department. Now that means in sklearn faculty, sorry, in the processing department at the sklearn faculty, import, what are we trying to import? So we want to import standard scalar. Please try to look at the what do you call it? At the case. So we have standard scalar. So you can see standard scalar is more like is one of the two that is you can use to can use to what do you say? You can use to change from English words to num to not not num to numeric words. Sorry, numeric data type. So we have standard scalar. So we also have different type of preprocessing. Maybe I'll just do Control C, Control V. So in this case, the same thing, but instead of standard scalar, we also have something called one hot encoder. So for the last one, we also have the same thing. I think we have standard scalar, one hot encoder, and label encoder. So as time goes on, we see the use cases of everything. But for now, we don't need label encoder. We don't need one hot encoder. We only need standard scalar because that is what transform English words to numeric words and numeric data type. So now let's just change this one. Let's delete this one. But then you have to know that we have three types of prepare system. We have our standard scalar, we have our one hot encoder, we have our label encoder. And you take note of something, you should take note of the case where it attach each word with sentence case, that is each word with capital letter then or the small letter then the second word or the second word I started with was another capital letter. So that's how to move here. So let's just delete this one. So another thing I want to do, okay, after I'm done with my pre-processing, that is I've changed it from English words to what do you call it? To machine learning model. So sorry, I've changed it from English text data type to numeric data type. I think that's better. So now to numeric data type. Now I'm actually trying to load it into my model, which is the next thing. So I will also write from sklearn. So in this case, what department am I trying to call? I'll call model selection. So please let's understand. Model selection as an underscore when I'm writing it. So sklearn model selection. What type of model am I trying to do? So now let me just use this one so we can understand better. So now let me explain this data set for us. So we can see this data set. We have row number, we have customer. So this is like a churn data set. And this 1 0 means if they are still in the company or they are not in the company, that is they've left or they are still in the company. So we actually want to know if they will be with us. So let me just explain this data set again. I'm just trying to jump, which I'm finding it hard to move. So when we say anything churn data set, that means customer churn data set. We want to know how many people has left us and how many people has stayed. So we all know that 1 is signifying yes, while 0 is signifying no, that is they've exited the company. So obviously no industry or no organization or no startup or no whatever we want to call it, they don't want to lose their customer. So maybe if you lose like 50% of your customer from inception, you want to look at your what you are doing wrong. Is it because of the cost the thing in your superstore is, or is it because of toxic environment? Is it because you guys are doing less quality products? Those are the things you want to look at as a store owner, as a CEO, stuff like that. Sha. So now we've gotten these are what do you call it? These are our data sets. And we all know that my Python cannot understand all these English words, which I want to change um to number, because Python can still understand all this number. So, but I want to change it to number. So now we now have something we call X and Y. So X is like the main data set. Y is or signifies the result. So we've seen that this is a customer. This is one. This is a customer. This is name. This is credit score. This is geography. That is where he's based in. This agenda. Okay, she's Asian. These are tenure. That is, she has spent 2 years with us. She's a customer for 2 years, and our balance currently is zero. And you can see number of products that she has bought. She has always been buying one product for the 2 years, and she also has a credit card. And an active member she was an active member because she exited. One means she exited, right? So now, what do you think is the result after these are all the information, right? But then the result is that at the end, she exited. This particular girl, you, she's still with us. She's still in our company, right? So we want to know how many people exit our company and how many people is still with our company. So this exited is our result, because basically it is either you've left our company or you are still with our company. So this particular column is what we signify to as Y. We do call Y targets, because it's like the outcome. Sometimes they do call it outcome. It's like the outcome of all the data sets present here. Why other data sets, which are here, all these columns are what we refer to as X. Do you understand? So the first thing you want to do when you load your computer is that you want to clean your data set. But now the next thing I want to do is that I want to change all these English words to what? To numbers. So if I change it to numbers, and that's what I called pre-processing the other time. So after I've changed it to number, I want to split it into X and Y. So we all know what X is now. We all know what Y is. So when I'm done with my splitting, let me just say splitting. When I'm done with my splitting, then I can now load it into my model. We have different type of model, but let's just say I will be loading it inside my model, which is machine learning model at this case. So you want to pre-process, when you are done pre-processing, you want to split it. When you're done splitting, you want to load it into your model. Do you understand that? Now let's move on, which is why I'm asking model selection. So let's import my train test bit. So from that, um, let me do it one by one. From that, you can easily say I'm actually trying to import. I'm trying to split my column. Okay, move on. So what should we import? Okay, again. Let's say from sklearn again. So now the model we want to use, we have different type of model. We have the SVM, we have linear regression, we have logistic regression. So we have different type of models. So let me just say linear model. So we have different type, but as time goes on, I will show you. So linear model, we have two type of model here. We have linear regression. We have linear regression. We also have logistic regression. I will show you the use cases of the two. So we also have, instead of linear regression, we also have logistic regression here. So let's run this. So let's see if there's any mistake. Okay, still running. Okay, we can see it took 3 seconds to run all this, but then we are done now. We've imported all this thing. Please, if you don't understand any of these libraries that we've imported, should I go over it or we can move on? Anyone? Okay, if you understand it, can you reply with an emoji?
Sorry, please, can you go over the linear regression?
Okay, do you understand to train text split here?
Yes.
Okay. So when you are done splitting your data set into X and Y, so obviously we processed it, we split it. The next thing is now, okay, we now split our model. We have different type of machine learning model. We have logistic regression, we have the SVM, we have the KNN. Okay, maybe I'll just write it. We have linear regression, we have logistic regression, we have logistic regression. We have KNN, we have SVM, we have s- um so it's how different type, sorry. We have PC, we have random forest, we have random tree. Okay, so machine learning model is just like linear regression now. What are the use cases? I don't want to jump. Let's just do it one by one. But just know that we have different type of model. We have the linear regression, we have the logistic regression, we have the KNN. I think this is something neural network, K neural network. I can't remember. Then we have our SVM, we have PCA, we have random forest, we have random tree, we have the um we have RGB boost. We have a lot of machine learning models. So these are the model that will help you predict. Now let's say I feed it with all this information. So basically, let me just tell you the backlog of everything we are trying to do. I feed it with all this information, right? But okay, how many data set do we have here? Maybe this if we take our time, but we understand it, at least we that's a good stepping stone. So let's say how many data set do we have here? We have 10,000 data sets, right? So why are we even splitting? What's the meaning of splitting? So what we want to do here is that please let's pay attention so we understand. So we can see we have 10,000 data sets. You want to know zero means people that are with us, one means people that have left us. Abi. So now we want to feed this computer. Let's say we want to feed it with like 8,000 8,000 let me write it here. So we have 10,000 rows of data. Okay. So out of these 10,000 rows of data, we want to feed our model with 8,000. So this 8,000, the computer or my model is supposed to look at the relationship. Okay, if this person is of this age, maybe if this person is male and is of this age and he has a credit score of he's buying this amount of products, he has a balance of this one, he has this, there's high probability that this person will still be in our company or will have existed. So I want my model to look at the relationship and I will feed it with maybe let's say 8,000 words, 8,000 data out of 10,000. So it will remain 2,000 again. So this 2,000, this is what I use to train my data set is what we call train data, right? What I'm now the next 2,000, 2,000, we have to add 2,000 to 8,000 to make complete 10,000. So the last 2,000 will be our text data type. So I will now test my computer with maybe one out of the text data type. I want to know, okay, how correct is this information? 8,000, look at the relationship of all the data sets. Study which one is one, which one is zero. That's basically what train data set is. Why text data type is more like, okay, since you studied this information, how true or how correct is your text, your text data set, how correct is it? Is it like 90% correct? Because now when your model look at the correlation, it may give you like 70% um correctness because obviously you can't have 100% absolute correct model. There is not it's even bad if you have something like 100%. So you can't see computer is not that's why the usual ChatGPT usually say conduct your uh, prescription or ChatGPT can make mistake because their prediction level is not up to 100%. It at most it can be 99.9999, but it can't be 100%. But most of the time it's usually 90, 91, 92, not like 100%. And that's why ChatGPT will make mistake. And if you correct it, it will admit to making mistake because the models they are not 100% correct. So now these are the train data, train data. So let's say I'm now asking my computer that, okay, out of this train data, what's the percentage correlation? Because obviously my computer has the old 10,000, but from the relationship he has studied here. So if he based my text data sets on it, how many percent correct? Um, how many percentage will be correct? It may give us something like 70% if we use linear regression. That is, we have different type of how have I written this? We have different type of models. We have different type of models. Now, linear regression can give me like 70%. Logistic regression can give me like 75%. KNN can give me like 20%. SVM can give me like, all this one they can predict in different ways. So you want to pick which one is most accurate, and that's why we have different models here. But because we are not discussing about models here. We just want to talk about these two models, which are linear regression and logistic regression. So that's why I'm asking sklearn.linear model. So under these departments, I can have my linear regression and also have my logistic regression model. Do you understand now? You understand? Don't.
Yes. Thank you.
Okay. Okay, good. You're welcome. So now let's run this again. So obviously the next thing I want to do is I want to upload my data set. So let's upload our data set here. The data set is here on I think it's Capstone Project 17. So the next thing is, can you see on this Capstone Project 17, when you look at it, when I over it, I can see something like Microsoft Excel worksheet. So it is not CSV, so it is Excel worksheet now. So now let's run it. It's loading. Can you see it now? So the next thing is you want to copy the path. So let's close this one. So the next thing is pd dot read. What will be this be? Will it be read CSV or read Excel? What do you think? Anyone can mute your mic. But Fiat, are you with us?
Excel.
Excel.
Thank you. So it will be read Excel. So open your brackets, put your quotation mark, the part I've copied before, Control V, then run it. Obviously, I want to store this inside the variable. So I'll write there. So it will be callable. Control Enter. Okay. Control Enter. So now let's press my line forward. So we can have our DF now. We can call our DF now. So these are our stuff here. So I think I've explained the stuff to us, how it works. So because we'll not be needing row number, so let's just look up all those rows that we'll not be needing. So row number is just like 1, 2, 3, we'll not be needing that. So df dot drop, open your bracket, columns equals to what columns are we dropping in? So we want to drop row number. So let me just copy it. So you can see it done. And we all know the significance of in place. So you just want to write something like in place equals to 2. So let's run this. So now if we should put our DF now, you can see the row number is done forever. So we can see. So please just give me 2 minutes so I can start something. Okay. So let's start with let's continue. Sorry. I have to do something very, very important. Okay. Now let's continue. Which what's the next thing? Okay, the next thing is you want to know how to change all this to obviously we don't need the surname also. So I want to remove the surname. So let's just look at the thing we're not needing. I don't need customer ID, I don't need the surname. So maybe we need the credit score, geography, age, tenure, balance. We need all that, but we don't need the customer ID. Customer ID is more like my tick number. Nobody needs that. And surname, obviously, you don't need the surname. It's not based on your name. Maybe you will leave or maybe you will not. So let's just remove all those things. So DF dot drop your number. That is, I want to drop something inside my data set. What do you want to drop? A column. So you can just write a column here. Columns equals to what is the column? I want to pass a list now. Let me see. Customer ID, then comment. What's the next name?
Surname.
Comment, thank you. So first name. So you can see both of them are done. So you just want to add the increase equals to 2. I believe everyone knows the significance of the increase now. So you should not be going back and forth for that anything. So control enter. So let's look at our DF now. So basically, these are just what we need. We need our service for geography. Let's just use obviously when you look at your data, you just have to get some information about it. So let's look at it. I'll be very fast about that. Information. Okay, we don't have any null value. Everything is 10,000. So we also have int because we are trying to work with machine learning now. So we are majorly focused on int or float, that is the numeric data type, the whole number or the decimal number, which is float. So all these objects are major constant, which is something we want to change into there are something we want to change into what they call it into numeric data type. So this object. Okay, now when we have geography and gender. So now let's just look at geography. Here, call the column. What column? We want our geography column. Um, how many countries are okay? To get the unique geography, so you just write unique. So we've done all these things in data analysis now. So we have three geography. That is our customer can be either in France, Spain, or Germany. So let's look at the gender. How many gender do we have in this particular set? So please don't assume that, especially if you are working with the any Western company, please don't assume that we have three gender. We have more than sorry, we have more than two gender. So the next thing I want to look at my gender. So obviously I want to look at okay. So you can see you have female and male, which is something of concern majorly. So now let's try to change this one into all these France thing. Majorly maybe France I will label it as 0. Anytime you have France in my data set, I want to label it as 0. Anytime I have Spain in my data set, maybe 1. So just that I can convert it into a number. Basically, that's what I want to do. So now the first thing I will do is what in this library, who can tell me which one will convert it from X data type to numeric data type. I think the other time. Anyone?
Standard scalar.
Okay, thank you. So that would be the first thing you want to call. You want to write something like let's just say label and coding. Now we all know that this let me just say LE. This LE is like what they call it variable. So let me just say XT. So you know that XT stands for standard scalar. Okay, maybe SS. So it's not rigid. You can use anything there. You can just write your standard scalar. So let's call our standard scalar. So you have to call it to activate it. Can you see? I've called my standard scalar because I want to use it. So I'm calling it activate it, control enter. So you can see it is now activated. So the next thing is what column do I want to change? I want to change this column now. Control C. Carry do control V, something like dot. What do I want to do? I want to use this. I want to use in this column. I want to fit and transform. They cannot do the right thing. Like, okay, I think this is how I'm actually supposed to write it. Because this is my standard scalar. I'm actually supposed to call my standard scalar. Remember, what's my label? Standard scalar dot fit transform. That is fit transform is more like and inside inside this column, what column now? Let's say geographic column. I want to transform it um numeric sorry, take data type into numeric data type. So you have to call the column here. What's the column? Here, here, as in geography. So let's run this. We have an error. So if we not convert this string to float, there's an error. They said to not convert the string to float. Mm, Let me check for gender first. Was I supposed to run? Okay, let's let's try for legal encoder. I think that will work. Run this again. Mm, What are we going to send? I think this one. I'm sorry. Okay, it does work. Sorry, I'm coming out of screen. I'm trying to look at something. I'm sorry, just give me a minute. Let me check. Okay, they have okay, please I think this is correct actually. Okay, let me check consistent. I think Kalima or something. Okay. So I will still explain. I'm trying to look at I want to know what I'm doing is correct. 0 and 1 now. It's not correct. Oh yeah, it is. This gender. Oh, it's supposed to be label encoder. I think I was the one that did the mistake. So instead of using standard scalar, please use label encoder to change from labels, to change from text data type to numeric data type. I think I was the one that did the mistake. Okay, so let's continue. Once it starts, we can just so we can see this how to transform it. So now let me just try to do this again. Sorry, I was actually supposed to import label encoder. That's where this problem stem from. So label encoder, please just try to, it's the same thing. So now we've got our label encoder with LE. So we want to do LE dot fit and transform, fit transform. So what are we transforming? We want to transform what's colon? Obviously, we want to transform DF. Let's say in this case, we want to transform geography because you know geography is like three country there. So let's say open your column GOU. So you can see your geography here. So you just want to click it. Then I you run on this one, you press on, you can see 02001. So now because ordinarily, if you look at this here, you can see my gender has been transformed already, but my geography is still France, Spain, France, Spain. Even though I've done fit and transform on geography. So that's why you have to copy this particular thing. That is inside this particular column, inside this geography column, you want to do control V equals to, that is this particular column should be transformed into 0123. That's why I called it. They will run it again like this. So if you run our DF again, you can see my geography has been changed into it. So let's look at something. DF geography that's unique. Can you see you have 021 because you have three different countries. So 0 is representing a country, 2 is representing a country, 1 is representing another country. So now if you look at our data set now, here, you can see everything looks good for machine learning now. Because you can see all these are now converted from numerical data type, sorry, from text data type to numerical data type. You will understand that, but should I go over it again? It's perfect. They're playing already. Should I go over it again? Rafiat, do you understand?
I have a
Rafiat,
question.
okay.
Yes. So for that DF geography, like we can just name it anything, right?
I'm coming. I'm coming. Um, do you hear something like? Okay. Mm. Okay, you were asking a question, Rafiat. The other time you were asking a question. Can I hear you now?
I said the DF geography, like can we just
Uh,
name it anything, or it must be that column?
I don't get. So let's say this is a
Like,
new line of
okay.
code now. Like DF, I should rename the colon, or what do you mean? Now this
I
is DF
meant,
geography. You were saying something. I want to understand what you are trying to say.
yeah, not this
Okay, maybe
side.
I should just
Oh,
go back. Okay, where?
no.
This one.
Okay. This one, yeah.
Is it this
This
one?
one, like
This one.
yeah, yeah. The way we assigned
Okay.
DF geography.
Okay, maybe we
Do
could
you
have
get
named
me?
it another thing now. Yes, we can.
Yes.
We can. You can just say instead of GF geography now, I can just say let's say geo. You understand? So
Yes.
so if I should look at my DF now, I will be able to see that there is a new word called geo, here, right? So normally geography will would still be with will retain plan stuff. So I can just drop my geography. Do you get?
Yes, I get
You
now
don't
because I
understand?
think that one is kind of wrong. Yes, I get now.
Yeah. Like you can drop this geography because geography we still have English text. You understand? So you can drop it. I'm just trying to do to the answer. So to drop it, you just call df dot drop. So if you will open your bracket, what do you want to do? I want to drop a colon, right? S equals to what's the name of the column? Geography in place equals to 2. So then you click. So if you call on your df again, I'm waiting for it to load. Okay. I guess I'm listening. Okay. So I can see my geography here, my exited is still there. So now that's good. So basically that's how to change from one data type to another. So after we are now done with this, the next thing is we are done with our what do you call it, pre-processing. Now the next thing will be train text state, which is we've imported this one. So you want to do something like this. Please let's look at this splitting of data. So the next thing we want to do is that we want to do something like okay, I wonder how Excel understand sorry, this thing, you understand everything. Now X, what is my X? You can tell me what's my X in this data set. Okay, what's my Y? Let's start from there. What's my Y in that data set? Anyone? Don't know either. Tell me what should be my Y in this in on all of this column. Don't know. Ah, I think she's not with us. Okay. Either ways, these are our Y. This edited is our Y. So we want to split our X basically. So to split X, it will be DF. My X is DF, like all the data frame, except one column. What's the name of the column? Exited, right? So you have to do something like the drop colon exited equals to what's the name of my column? Exited. So what's my Y? My Y should be something like df. So I don't know if you understand this line of code or fiat. Do you understand? We are trying to split the data. Now X is all the data frame. DF means all the data frame, right? That's the meaning of DF. So inside the data frame, I want to remove Y, and that's why I'm calling drop a colon, and the name of the column is what? Um, is exited. But Y should not be the dropped column. What's the name of the dropped column? That's DF exited. So if I should run this now, so if I should call on my X, look at something. If I should call on my X, I will have all the data sets, all the columns, except, sorry, except exited. So if I should call on my Y again, can you see it is only showing me exited? That means I've splitted it into two. Do you get that, Rafiat?
Yes, but are we going to be having exited in all the data sets?
No, now you have to know which one is your Y. As why you will be your result. This is a churn data set. You want to know who has left, who remains. Do you get? So in this
Okay,
case,
okay.
why exited means they have left one. Zero means they are still with us. Do you get? So this is the result, and that's why it is the column you are using. Do you get that?
Yes, I get now.
So after then, you're almost done with the class. So after then, you write something like x, and this one can be a little bit tricky. So x test, comma, string. Sorry, I'm not supposed to start with string. X test, comma, y equals to. I'm coming out with explaining. Test size equals to 0.2. 0.25, 0.2. And we have our random states. Okay, great. Now let's run this. Position arguments for the keyword. This is supposed to be recipe. Okay, it's fine. So now basically this is what we want to do. This was what I was explaining the other time. Now we know what our X data type is and what our Y data type is. We know that we've separated X and Y. But now I want to separate it. I've separated my column now, which was what I was trying to extend the other thing. Let me call it so everything here, everything you can see here, everything you can see from this space, from column A to column M, and my X, what everything you can see in this column O is my Y. So I want to split it. We have 10,000 rows. I want to use a part of it to train my model. I want to use a part of it to test my model, to know the accuracy level of my model. So instead of feeding it everything, I will be feeding it like 80% of my data, then use 20% to check for accuracy. You understand? Basically, that's what I'm trying to say here. So S-train, that is, I'm splitting it into the training data set and text data set. So I want to split S-train, that is my S data type, and S-test. I want to split my X into X-train and X-test. I want to split my Y into Y train and Y test. You understand? And remember we've we've imported something called train test split. Do you get? So inside your train test split now, I want to call my X. Remember, what's my X? That's the data set. This is my X here. What's my X? This is my X here. So guys, what's my Y? This is my Y. We all know Y now. Then this test type is mean like, okay, how many percentage do you want to test? If I'm testing with 20%, that's 0.2. What do you think will be the difference size? Rafiat,
What do you say? For 20%, you
if
said is
test size, what do you think will be my difference size? If test size is 20%, how many percentage am I using for the difference size?
yeah.
That would be 0.8 now. That would be 80%. Shibi.
That's 80 since this one is 20.
Exactly. So this random
This way
state
you
is more
said you
like,
can't get 100%.
no, not now. That one is not applicable to all the step I'm doing now. All I'm saying that we
Okay.
are trying to split it into train data type and text data type. You get? And my train data type in this case is I'm splitting both X and Y into train and test data type. Then I call my model, the one I imported data type. I call my X, I call my Y. Then I'm now
Yes,
informing
I
that
get now. Yeah.
okay, so this one should be 0.2. This random state is more like when you are repeating this particular line of code, if you write random state is more like the random level. That is, whatever I get is what you get if you are repeating this video with me. So if you just call on this one now, so you can actually see that let's say something. Let's call it. So if I should call extreme, so because I'm using now, I want you to say something. I want to call string dot shape. That is, I want to know the number of rows and column here. So how many rows of column do you think? How many rows do you think will be in our X string? If we use 20% for text, how many do you think will be in our training data sets? That would be what? 80% of it. What's 80% of 10,000 rows? That would be how many rows? 8,000 now. So if you should run this one, I can you see we have 8,000 power training data sets, which means it is running very fine. So Control C. Let's do that for text type.
The question
Okay, what's the question?
isn't that is the computer that'll pick or the program that'll pick the row the columns that is going to use.
For training and testing, Abby.
Yes.
Yeah, exactly. It is the computer that will pick it.
Okay.
Okay. So yeah, basically that's everything we are learning today. I don't want to rush us with a lot of new information because they are new. So the assignments, after we communicate better with us. So the assignment it will be just to replicate this line of code. There are just 48 lines of code, so it's very, very easy. And I think the video should be under 1 hour. So it's very okay. You have a question? Okay.
Yes, I had a poor connection the other time. You said X underscore train. Even I can see your screen, or you're not more sharing it.
You can see my screen.
Yes, I think maybe probably it's network. You said X underscore train dot shape,
Okay,
right?
let me join again.
You now said okay.
Okay. Why can't you see my screen? My screen is running fine here.
I can see
Boom,
it
can you see
now.
my screen? I think it's your network, it's not mine. And maybe it's mine. Who knows? Okay. You were saying something.
I
Ah, I
can
can
see
hear
it
you.
now.
Yeah.
Yeah.
Oh, okay.
So you said okay, is this part X underscore train dot shape?
Yes, I was trying to ask that
So
if we
you have
it's if we are testing with 0.2, obviously our train dot shape should be 8,000 because training is 80% and that should take 80% to 8,000 rows. White test should give us 2,000 rows. So the same thing if I'm doing y white test. Now let's say white test dot shape. White test dot shape. How many rows do you think will be in my white test dot shape? How many rows? Oh yeah, reply now. Rafiat. Actually, not there. Don't me reply.
So what's the question again?
Like I said, if I'm calling this code now, white test dot shape, how many rows do you think will be there? That will obviously be 2000 now. If I should run it, then that's why I'm having 2000 here. Okay, so no problem. So this is where we stop for today. If you have any question, you can just ask me. The assignment will be you should um replicate everything we've done, and after we communicate better with everyone. I think I break it down and I tried not to rush it. So they are very easy. It just look like complex thing, but honestly, they are very, very easy. Okay. I guess this is where we say goodbye for today. Have a great day, everyone. Bye. Welcome.